issue with my audio. I just said that the floor is yours, and
got it. All right.
There are a bit more people, less people than expected, but they'll get probably some of them will get the recording afterwards.
Okay, sounds good. So, hey everyone, Jordan Lass from Dimension Labs. We are building TypeScript and Python CDKs for the internet computer. So basically, I'm going to take about 30 minutes to show you how to use the TypeScript CDK. And then Bob, after me, is going to show you how to use the Python CDK. So let me just share my screen. Okay, so the TypeScript CDK is called Azle. The main entry point right now is just the GitHub repository. Here it is, github.com/dimensionlabs/Azle. We are working on doing a major upgrade to our documentation, and we're building something called the Azle book. This is definitely not done yet. It is live, but we're just constantly working on it. So as I go through the presentation, I kind of want to use the book as our reference because we're designing it so that it builds concept by concept and is really designed to be kind of an in-depth guide that will just take you from basically knowing nothing about the internet computer to actually being able to develop in TypeScript. We'll also build the same thing for Kybra, but for now, we're just starting with Azle. So let's just build an Azle project. So we're just going to start basically from the beginning. So, just imagine you're doing an entirely new project. Here's a blank terminal. I've already created a directory for the Motoko Bootcamp for January 2023. And okay, here we go. Basically, I've just made a new directory. Nothing's in it except this target directory. That's just so that it compiles faster during the demo. And I've opened it up here in Visual Studio Code. So there's basically nothing in here yet. So first step is there are a few prerequisites that you need to install. In the next version of Azle, it's just going to be npm and node and dfx. The need to install Rust will be gone, which is pretty awesome. So you can basically see all the prerequisites and what you need in the installation section. Once you've installed the prereqs, you just install Azle. Oops. Got to load npm. You probably don't have to do that. Okay, so Azle's installed. And notice it's made a package.json, a package.lock.json, and a node modules directory. These are all very standard common things. The only thing we have in here is our Azle dependency. I'm just going to make a source directory to put our code in. And the entry point by convention is index.ts. So we just have a TypeScript file. Before we get going on that, let's make our dfx.json file. You should be pretty familiar with the dfx.json. It is the main configuration file for canisters on the internet computer. Right now, it's just easiest to copy paste this from the documentation. So there's an example dfx.json right here. We're working on making it even, I guess, a lot simpler. So backend is the canister's name. So I'm going to change it to Azle demo. That'll be the name of our canister. This configuration file is just like you would see in Motoko or Rust. It just has a few more fields. And now let's just do a simple hello world. So we're just going to import query from Azle, export a hello world function with query as the return type. And then you put the actual return type of your function inside of the query return type. Why hello world? Okay, so this is like the most basic canister that you could possibly create. We export one function. It's a query function. Query functions don't persist their state. They're very, very fast to execute. And there you go. So let's spin up a replica. I always like to make sure it's clean. And I prefer to have the host on this exact port. So we'll spin that up. I'll open up a new terminal, and basically all the commands are going to be the same commands that you know and love from DFX already. So once this spins up, it's up. We will just do a DFX deploy. Okay, so this will take just a bit. Right now, compile times are 15 to 30 seconds. We're hoping to get that down to 5 seconds or less in the next few months. Okay, so 24 seconds for that one. This is also the first. Okay, well, let's deploy. So this is just the canister like any other now. So we can just use the command line. DFX canister call. The canister's name is demo, and we made a function called hello world. And there you go. Why hello world? So that's a query call. Very simple. Not too much going on. Let's introduce the next concept in our logical progression here, which is the idea of an update call. So you just import the update type from Azle. Update calls allow you to persist state, right? Query calls, you don't get to store anything and retrieve it later. It just gets thrown away at the end of the call. But an update call is going to let you actually store things between update and query calls. So let's just create a little global variable up here called message. It's just an empty string, nothing crazy. And let's modify our hello world function to return that message. And let's rename the function to get. So let's make a very simple getter and setter. Okay, so set is an update function. And we'll just pass in a variable called message with an underscore. There we go. And we'll just return the message for good measure. Okay, simplest getter setter. We have a global variable up here. This will persist across query and update calls. The setter is an update call, meaning it's going to go through consensus, take a couple seconds, but it will actually be able to store information. And then we can just use the getter to retrieve it. So let's do our first deploy. Azle is going to generate the candidate file for you automatically, FYI. So we'll see this change very soon. Okay, it's doing this check because we changed our candidate interface. I'm going to say yes. And from now on, I'm going to tack on a command to DFX deploy that will just do that automatically. So I'm going to say -y next time so that it won't ask us anymore. Okay, so notice the candidate file is automatically updated. We'll just ignore that from now on. Just know that it is automatically doing that. And now here we go. We've got our getter, we've got our setter. So let's get the message. It's just an empty string right now. Let's set the message. Why, sir, hello. Okay. If the getter works, okay, there we go. So it is persisting across update calls, which is pretty sweet. So we've got the concept of the queries, the concept of the updates. The next concept we'd like to introduce is all the basic data types that you have available to use. So we've been using string. That is just a built-in TypeScript type that is, the string that you know and love. But you can also use basically all of the candid types that are available. And if you go to the reference section of the Azle book, you can see all the types that are available to you in candid. So you've got your primitive types like bool, blob, all your numbers, your floats, your ints, your nats, your op type, null, principal. Then you have your non-primitive types like record, which lets you create basically objects with key value pairs, variants, and such. So generally, you can just import the type that you need straight from Azle. So for example, NAT64 comes straight off int blob. Most things that you need, just import them. Generally, when you're working with numbers, you're going to use the NAT numbers because you can fit more number in there for the space that is allocated for the number. And generally, we're not working with negative numbers in the crypto space. If you do work with negative numbers, you have to use the int types. But NAT64 is generally a good number to just pull off if you're just starting. So let's change our message to be one of these numbers real quick. And it's a big int in JavaScript, so you have to tack on this n if you're doing a number literal. And then we'll just change our getters and setters. So it's a NAT64, NAT64, NAT64. So I mean, nothing crazy. We'll just pull that real quick. So primitive types, relatively simple. Simple getter and setter, also relatively simple. Now, probably the next step is you're going to want to create custom data types for your application. So that's where the record and the variant types come in. Making a record in Azle is super easy. It's just a simple JavaScript object, and you just use the TypeScript type syntax to do it. So if you want to make a user, for example, you just make a type called user. And what is it? It's just an object literal. So you might want it to have an ID. For example, you might want to use the principal type. So we'll just get that straight off of Azle. And now you've got yourself a user record. The ID is a principal. Username is string. Nothing crazy. Okay, let's test our previous getter and setter. Get is now a NAT64. And set now is some number. And we can get that. Okay, sweet. Okay, so now that we're going beyond these primitive types, we kind of need more, like a more complex state management system. It'd be nice to basically start to implement a simple database here, because message is not sufficient for the storing the complex records, variants, and other things that you need to actually build an application. So let's just get rid of the message. What's nice is TypeScript is automatically doing this type checking for us. So we gotta keep going until the red squigglies are gone to feel pretty safe here. Generally, when I'm making a database for these types of applications, I like to just store things in a simple variable called state. And I like to just give it a simple type. There's a state type. And I'll make sure that this is of type state. So they'll give us type checking. So we want to store all of our users, and we want to be able to retrieve them by their IDs. So inside of our state, let's make a users object. And inside of here, let's say that our keys will be strings and our values will be users. So what this is telling us basically is that we have just a plain JavaScript object at the highest level. It has a property called users, which itself is an object. Basically, it's a hash map with properties which are just key value pairs. The keys are going to be strings, which will basically be the stringified version of the principal. And then the values will be the users themselves. So this type is good here. And so this is just the TypeScript type. You just need to define it to help you with type checking. And then here's the actual JavaScript runtime value, which is the actual object with users in it. So this is all you need for a very, very simple database. I don't recommend generally using lists or vectors or arrays for your database. You'll quickly find out that it's very difficult to retrieve specific records because you have to iterate through everything. It's easier to use these hash map type structures. So let's start updating this. So let's create a user. Creating a user must be an update call, and we'll have it return a user. And then let's have something to get a user, and you can just pass in the principal. Let's introduce you to the concept of an optional type. When we're retrieving a user, what if they pass in an ID that isn't real, right? So you need to be able to express the lack of a value, and that's what the optional type will do for you. So getting a user is pretty easy. We'll just return state.users, and then we'll just turn the principal into a string, basically. If it's not there, we'll use nullish coalescing to just return null. So that's how the opt type works right now in Azle. Either the value is there or it's null. So this get user method is should be pretty robust. Then creating a user. So we definitely need an ID, right? And to do that, we can build ourselves a little U into 8 array. And we can, this is just a little hack, we can just get basically the length of the keys in the database. Oops. Throw that into the principal.from U into 8 array method, which will return a principal that will just, it's just an auto incrementing principal. So the first one will be principal 0, then 1, 2, 3, 4, 5, go from there basically. Then we can actually make our user. So I'll type that for you. Now, the ID is actually going to be that principal.toText for easy retrieval. And then the username will be whatever we passed in from the top there. Oh, no, sorry. The ID is just the ID. Thank you, Typescript. And then finally, we want to actually store. This is where we'll do ID.toText. And now we've actually, so we've created the user. We have stored it in our map. Here's the key. It's just the principal turned into a string, and then there's the value. And finally, let's just return that user. So we can create a user. We can get a user. Don't need Net64 anymore. Okay. All the workings of a very, very simple database. Let's deploy it. Now, something to keep in mind here is that creating users is going to persist the users across update and query calls, but it's not going to help you if you ever upgrade your canister. To deal with upgrades, we need a more powerful mapping structure that basically allows us to write into stable memory. And stable memory is a memory location that will persist across upgrades. It's just like, just like the heap, this is stored on just the main canister's heap. Very easy to retrieve. We need to, instead of writing to the heap, write to a stable memory location, and we will introduce that concept in just a second. Okay, so let's try to get a user. By principal, the only principal I really know off the top of my head is this principal. Okay, it's null. There is no user with that thing. Makes sense. So let's actually create a user. Username, last name, JS0. There we go. And if I go try to get that user, I can grab its principal here. There it is. Pretty sweet. Okay, so we've got our simple little database here, but check this out. Let's add a method to get all of the users. So I'll just call it get users. It's going to return an array of users. Okay, this will just basically get all the values from our state.users object, turn it into an array. Let's deploy this. And notice what happens. It's going to completely erase the database because it was stored in the canisters heap. And generally, you don't want to erase all your data. Sometimes you might. Okay, so let's try to go get the user that we already created. Well, it's no, everything was erased. So let's use instead a stable mapping structure called a stable B-tree map. It's going to do almost the same thing as this JavaScript map here. But like I said, it's going to write directly into stable memory. You don't need a post or pre-upgrade hook or anything. It's just in real time right into stable memory. So let's just rewrite this to use a stable map. So we're going to call it a users map. This is a new stable B-tree map. The keys are strings, the values are users. You need to put in a memory ID. So every stable map needs a unique memory ID. The easiest thing to do is just start at 0. And if you make another map, you say 1, then 2, then 3, then 4, then 5. You also need to specify the max key size and the max value size. For now, I'll just say our max, from before, I know that 29 will work and then 100 will work. So the keys can't be more than 29 bytes and the values can't be more than 100 bytes. So it's a little complicated to figure these out, but for now, that's just a limitation of these maps. Okay, so we've got our user map. Let's just go comment all this out and follow the squiggles. So to create a user, we can't do it like this anymore. But what we can do is we can say users map dot length. Sweet, that should do the same thing. And then when we want to store the user, we'll say users map dot insert id dot to text and then the user. Okay, so this should all be equivalent. Okay, so this length is actually a big int, so we just need to convert it into a number. So we'll do it like this. Okay, now that should be equivalent. Okay, this function should be equivalent. When we get our user, just say users map dot get id dot to text. Get automatically already does the opt for us, so we don't need to do the weird nullish coalescing. So that's cleaner. And then if we want to get all the users, we'll just say users map dot values. Okay, so we just rewrote it. It's even cleaner and shorter, and it should do the same thing, but actually persist across upgrades. So here we go. Yep, nothing crazy here. All right, let's first test our get users method. Okay, empty vector, perfect. Let's create a user. Last name JS 0. There we go. Last name JS 1. Last name JS 2. And let's go get all of our users again. Okay, they're all there. Now let's do something crazy. Let's add functionality for removing a user. You just pass principal in. And this will be an update that returns the user that you removed. And we'll just say users map dot remove id dot to text. What's wrong? Aha, opt. Okay. Okay, now let's deploy this. And remember, before it erased our entire database, but this time it should not erase the database. So this is a full, normal, regular deploy. Okay, and now let's try to get all of our users. And I really hope they're there. Okay, they're there. Sweet. So now we're writing directly into stable memory. And right now you have up to 48 gigabytes of space. You have to keep in mind the max key and value sizes, so you won't get, sometimes you might not be able to get the full 48 gigs, but still pretty large. And let me just introduce one final concept to you, and that's the concept of doing a cross canister call. So these principal IDs right now are not that good because they're sequential in nature. If we remove a user, that kind of destroys the whole algorithm here, because you might start doubling up on keys. So it'd be nice if we could do some basically create random principals. So one simple naive way to do that is to get some randomness from the internet computer itself. And you can access randomness through something called the management canister, which is a virtual canister that has a bunch of functionality on it. So if we just transform this create user function into an async function real quick. So now it returns a promise. We can now go get some randomness from the management canister. Okay, this does a cross canister call and will return a result that either has an OK value with the randomness in it or an error value. And we'll just use a little Azle shortcut to check that real quick. So if this is not OK, like if something bad happened, let's just return null. And we'll change this to return opt. There we go. If it is OK, then our randomness is inside of rand result.OK. And now we can use our randomness to fill up this here. We have to cut the randomness down in size, but this should work. Yeah, hopefully that'll work. I mean, I'm up on time now, so I think I'm basically done. So there you go. We walk through query calls, update calls, stable structures, candidate types, and finally, this is how you do cross canister calls. So I think I'll just cut it off right there.
Do we have any final questions for Jordan? You can put them in the chat or you can put them in the Q&A section. Would love to know if there are any questions about TypeScript on the internet computer, Azle. Jordan, can you see the Q&A section if you click on the Q&A on the bottom? I'm okay with you taking a couple questions.
Oh, okay. Could you show intercanister calls? Okay, well, I guess I could just finish what I was doing.
Yeah, that's fine.
Okay, so yeah, someone asked, can I do intercanister calls? So that's what this is right here. This is an intercanister query call, the simplest one you could do. So let's see if that works. Had a little bug earlier this morning. Oh, there we go. Yep. So now I got randomness from the management canister, and the principal is random. So that's cool. So real quick, I'll just show you how to do to some other canister that exists. So there's this canister type in Azle. So I don't know what some other canister, you just define a type for what other canister exists. And then you just put the information in here. So let's say there's a canister result type. Here's the basic concept. You define your canister, you put all the methods of the canister inside here. And then if you want to instantiate it, you say some other canister, which is of type some other canister equals IC.canisters dot some other canister. IC is an object from Azle. Oops. Yeah. Hold on. Sometimes it's finicky. There's tons of examples, by the way, in the examples repo, or in the examples directory of the Azle repo. So there's a cross canister calls example, which shows you exactly how to do this. Yes, so here's how you define them. I got that part right, and then oh yeah. Oh, and then obviously you have to put the principal in of the canister. Okay. You know, whatever your principal is. Okay, so here's some other canister, and then you just call it. There you go. That, just to be quick, define it, instantiate it, call it, and here's the result. So.
You have a few other questions too, Jordan. Feel free to tackle.
Oh wow. Okay, how much can you do with plain JavaScript? Can you find can you share libraries? So you can do a whole ton of stuff with plain JavaScript. You just need to make sure that anytime you interface with the internet computer, so canister methods, for example, the stable B tree map, anytime the internet computer needs you to define a type, we use TypeScript to do that. But you know, once you define your canister methods and your B tree maps, you can make whatever functions you want, have as many different files and stuff. That's just pure JavaScript if that's what you want to do. Variants are defined with TypeScript. And then JS libraries, yes, you can use JS libraries, but you can't use all JS libraries. It just depends. So you have to keep in mind that Azle is a different environment from Node, and it's a different environment from the web. The web has APIs that Node doesn't have. The Node has APIs the web doesn't have, and Azle is also a different environment. So we're going to work towards implementing all these APIs and make it as indistinguishable as possible from Node and the web, but it's just early and not yet. So you just basically npm install something and try it out, basically, and then you can open an issue in the repo. For the randomness, yeah, so I was making IDs that were auto incrementing, like 0, 1, 2, 3. That's just generally not best practice for databases. You want to have completely random and completely unique IDs, because what happens if you remove a record with an ID? Then you'd have to go through and search and make sure that you never use that ID again. Or it's just a best practice. So, and I was just showing how to do a cross canister call, basically. And then is it to simulate principles? Yes, I was just simulating a principle. Yeah, maybe that's the answer. I was just trying to show you how to make a random principle. Okay.
Cool.
I think that's it.
All right. If we don't have any other questions, Jordan, you want to take that last question?
Oh, sorry. In the Q&A, when you set the max limit 100 to the map, so what type of error will it throw if you go over 100?
The byte limit for the stable B tree.
Yeah, I'm hoping Azle will give you a nice error. And yeah, in Kybra, I think it's pretty clear. It just tells you, hey, you tried to. It'll tell you the exact size you passed in, I believe, and then it will tell you that it's bigger than the limit that you set. So if Azle doesn't throw a nice error, then that's something we should fix. But in Kybra, I'm pretty sure it throws nice errors to explain that. And yes, you're welcome.
Cool. All right, we're gonna move on to Kybra now. Kybra is everything that Jordan just said, but in Python instead of TypeScript. Can I just see in the chat who has Python experience? Anyone have Python experience? Give me like a number out of 10 on your Python skills. 10 out of 10, 9 out of 10, 5 out of 10. Just type it right into the chat. I just want to get a sense for how Python-y our audience is today. Oh, wow. Okay, we got a 0, we got a 0.5. We have some 5, 6s, 8s. A 2. Okay. I was going to do some like live canister creation in Kybra, but I think maybe it'll make more sense for me to just show you some of the Kybra code I've been working on over the past, how long has it been, Jordan? 3 months?
I think you got it. You got it in November. I think that was your first taste.
November, like mid-December. It's been like 2 months.
Yeah.
Okay. So I'm just going to jump in and show you some of the Kybra canisters I've been building. And then feel free to, I have the chat up and I have the Q&A up on this screen, and I have, the one that I'm going to share on the other screen. So feel free to jump in with any kinds of questions about Kybra. Okay, can you all see? I'm assuming you can see my screen okay. Okay, so let me show you a really simple canister that I built to test something on the internet computer. So notice how Kybra is similar to Azle in that you can import, all of your things from Kybra. Also, Jordan's a much better engineer than me, so I'll kind of hack my way through here, but Jordan can correct me if I'm wrong on anything. You'll notice here that I'm creating a stable B-tree map so that I can save directly to stable memory. You specify types, and then similarly as with Azle, you have to specify a memory ID, a max key size, and a max value size. Oh, you can't see my screen?
I can see
Jordan?
your screen. I can see your screen. Is anyone else having that problem?
Okay, it looks like Ellie is
Um,
having a problem viewing the screen. Okay, now you can see it. Perfect.
Cool.
Yeah, sometimes it just takes a minute. Okay, so you can see how in Kybra you define updates and queries using, I believe these are decorators. And then you define functions, and then you specify, what was that, Jordan?
I just think the decorators are really nice, and I wish we could do them in Azle, but TypeScript doesn't have decorators on methods unless it's within a class.
Yeah, so then you can see this is just a simple counter. And I'm just inserting numbers into this stable B-tree. The reason that I wanted to build this is there's actually an interesting thing about the internet computer. There's a deduplication of calls, even update calls that happen. So if you send like 20 update calls with the same parameters from the same user at the same time within like 150 milliseconds or so, then the internet computer will deduplicate those calls and just make one call. And so all 20 will return the same value. And that's undesirable in a lot of cases. And so I included this random number as a parameter. And when you include a different random number in every call, then the calls aren't deduplicated and you get the full 20 calls. Anyway, so that's one canister that I have. There's another canister I'm working on here. I'm just gonna take you through my crazy Kybra adventures. This canister is one that I'm building right now for Entrepot. Entrepot is the biggest NFT marketplace on the internet computer. We want to add user reputation and voting into Entrepot so that we can allow users to vote on collections and determine which ones kind of bubble to the top and which ones get on the featured page. So it's decentralized decentralized voting to determine which collections get on the homepage and things like that. So I have, you can see defining a record in Kybra is just with the class, and then the name as a record, and then you just define your keys and your values and your types. And these are all the reputation metrics I'm going to bring in for users. So I do all the computation on a Web2 server. It's just too much to do on the internet computer right now. I think it would be too expensive to do it all on chain. So I have a Python script that basically goes out and gets all of the transaction history for all these users, and then crunches down all these numbers and then saves it here to the canister. So you can see I'm defining a few stable B-tree maps. There's an admin one. This is how I essentially gate certain calls. I do admin gating, principal gating, and then this reputation metrics is the stable B-tree map for the, essentially this is how we're going to calculate reputation. So you can see I'm defining an init function. So the very first time the canister is deployed, it will add this principal as an admin. And then you can see later on that I am doing some principal gating at the beginning of some functions. So I'm taking the caller, converting it to string, and then I'm checking if admin, which admin is this stable B tree that I created up here, if it has the key of this principal. And then if it does, then I will go through and do the method. This is actually a cycles sending method. So you can see how I'm actually sending cycles using a cross canister call in Kybra. So I'm defining the canister. This is, right now it's kind of painful because there's a 2 megabyte limit to your WASM binary size. So when you deploy, it has to be under the 2 megabyte limit because that's the message size limit right now. And Kybra canisters are fairly big. I think I can fit like 500 lines of Kybra code before I go over the 2 megabyte limit. And so the workaround that I have right now is I have essentially a canister that deploys canisters for me. In fact, let me just bring up my canister installer code. So this is all Kybra. And you can see that I have an upload WASM binary function. And this is essentially uploading the raw WASM binary bytes to this canister. So it implements chunking because I want to handle more than 2 megabytes. And so, again, this is kind of a quick breeze, a quick pass through a lot of the Kybra stuff I've been doing. So if you have questions, feel free to throw them in the chat, throw them in the Q&A, and I can answer them. But basically, I chunk the WASM binary, upload to this canister. Then I have an install code. I think I have a create canister in here. Yeah, so first I create a canister. So you can see that the management canister has a create canister method and sends, X number of cycles to that canister. So from this, I call it my factory canister, my installation canister. I can create a new canister, upload WASM binary, and then I can install code. So from a specific WASM binary, I can then install code to a canister, or I can reinstall code like you saw here. And yeah, so this is my kind of canister installer. So this voting reputation canister can send cycles back to the factory canister. Using this kind of send cycles method, you can call any method with cycles. In Kybra, just using a with cycles there at the end. But yeah, I mean, I can build essentially whatever I want to build in Kybra. I'm not really restricted. Let me show you. I've been working on an NFT canister. The NFT canister is probably my most ambitious Kybra project. I'm up to, 2000 lines of code, but I've been able to do essentially everything that I've needed to do for an NFT canister. You can see transfer methods. You can see I've defined a whole bunch of different HTTP request methods so people can call and get NFTs in different ways. They can specify different kinds of views. They can specify different kinds of indexes or even token IDs. And yeah, I mean, it's pretty, the main purpose of my presentation, I think, is just to show you that you're basically uninhibited. You can do almost anything you want to do in Kybra. I think the main limitation right now is you don't really have the ability to import anything. Just because of the size issue, I think we might be able to get some pure Python imports now, doing this kind of installation factory hack. But you can see that like I have a, this is my randomness. I wanted to import random, but you can't really import random in Python in Kybra right now. I think you could, but it's just not quite there. So I have this custom Mercedes twister algorithm that I bring in, and then I can then call that. So, I mean, this is doing all sorts of crazy Python stuff, and it just works. You can see at the top, I'm just pulling in from twister random, and I import it, and it does all the craziness of the random library. So I actually get randomness from on-chain, and then I put that into the Mercedes twister as the seed. So then I can do a more true shuffling of addresses for like airdrops and things like that. So I can do like on-chain address shuffle. I would still call it pseudo random, but it's getting closer to true randomness because I'm pulling randomness from the IC. Anyway, that was kind of a whirl through all things Kybra, but wanted to leave a little bit of extra time at the end for any questions, just kind of broadly about Azle or Kybra from the audience. What kinds of things do you want to see? What kinds of questions do you have? I'm really, really excited about Kybra. I think, let's onboard the 14 million TypeScript devs, and let's onboard the 13 or 12 million Python devs to the internet computer. Building in languages that they already know and understand and like. So yeah. Any comments, questions? You can throw them in the Q&A. You can throw them in the chat. I'm curious how TypeScript and Python writing smart contracts compares to Motoko. I know you've all probably been super, super deep on Motoko. But yeah. Any questions? No questions? No questions.
Yeah.
I
3,
guess it's pretty simple.
2, 1.
Yeah, I guess it's just so easy to program in Kybra and Azle. Jordan, did you want to give any final like Azle and Kybra are the best final remarks?
Yeah, just keep in mind these projects are in beta, so they're not necessarily appropriate for every production use case you might have. You might run into some issues. Performance could be a problem. I think Kybra's performance is, so far we have no indication that it's materially bad, right?
I have a question.
Is
it possible to compile like a TypeScript, or in theory compile TypeScript or Python into Motoko and then compile to WebAssembly? And would that be like advantageous, or like how would that compare with the current versions of Azle and Kybra?
I don't quite understand. Like, put Python or TypeScript in Motoko? No. So I think the answer is no. You can't compile. You just cannot compile TypeScript, and you cannot compile Python into WebAssembly at this point in time. It's just not something anybody has ever done. You need to have a runtime to do it. So I don't think there would be any advantage at this point in time.
Okay.
I mean, it's more not nuanced and technical than that, but like, this is the most practical, probably performant way to do it at this point in time. Is you just take, I mean, that's JavaScript and Python. That's how they run everywhere. There is an interpreter, basically, or a runtime, and so you just need to compile that runtime for the environment that you're running in. On the internet computer, it happens to be WebAssembly.
Makes sense.
Dude.
Okay, if we don't have more questions, I think.
No, sorry, someone has a question. Will Kybra support async IO from 3.11? I thought async IO is in earlier versions, but yeah, our intention is to support async IO so that you can just do async await. That's our intention. I was going to start on that probably next week. And then the other question, so when you chunk to binary to make, I assume it's precompiled code. Yeah, it's the final WASM binary that you're chunking, right, Bob?
Yeah, basically you just run dfx build, and then you go and get the WASM binary. That's all ready to go, and you just get it in bytes, chunk it up, and then upload it to the factory canister for then installing to other canisters. Yep.
See, I think, I mean, the main point, in some ways, there's nothing to discuss. It's like, if you want to write your stuff in TypeScript, then you can do it. And if you want to write it in Python, then you can do it. That's the main point.
Any last question? Nope.
If anyone is interested in getting deeper on the Kybra side, you can ping me on Twitter if you want, and I'm happy to walk you through things or talk you through how I'm developing things. I've been going at it for 2 months now, so I've run into a few different kind of weird edge cases that Jordan and I have had to solve, but I think we basically have workable solutions for everything at this point. And so, yeah, feel free to, I'll drop I'm just at Bob Bodley on Twitter. Feel free to shoot me a DM if you want to start building code in Kybra. I'm working on a fungible token in Kybra, and I'm working on an NFT canister in Kybra. So then we'll have all sorts of, we'll be able to do NFTs and fungible tokens and all sorts of crazy custom configurable things all in Python, which I think will be really, really awesome. So.
And we have Discord. The Dfinity Dev Discord has TypeScript in a Python channel if you need help.
Yeah, I mean, we're a couple minutes early, but probably better a couple minutes early than 10 minutes late. I think it's a nice weather. Well, nice weather in Portugal. Porto. I don't know about anywhere else. It's kind of gloomy here in Utah. But yeah, Jordan, what about TypeScript or Kybra meetup, like conference? How far are we away from,
Well, I feel like we need more people. There's just a handful of us. So
yeah, what if there were 500?
Well, I mean, that's a lot of people. So
100?
Once
30?
we have, I'd say once we have like 100 people that are, I don't know, I probably soon. Just, yeah. I think yeah, that'd be really fun. I mean, we should try to replicate the Motoko Bootcamp experience somehow. So it's been extremely
Yep.
awesome. So
Thank you, guys.
Yeah, you're welcome.
thank you. See you.
All right, I think we have a next lecture in 2 hours. It will be the last one for today. So see you there, guys, and have a good one. Thanks.